by conservatively making the right choice. That is, can we ensure that the system never reaches an unsafe state by making some choices in the way processes execute or the way resources are allocated and so on. So, one way that we can build such an algorithm is by using what is known as a banker's algorithm. So, let us see an example with this. Now, consider a banker with 3 clients A, B and C. Each client has certain credit limits and the sum of all these credit limits totals to 20 units. Now, the banker knows that the maximum credits of 20 units will not be used all at once. So, he keeps only 10 units. To see what this means, let us say we consider these table with the 3 clients A, B and C, and each client has in his account some units. So, for instance, A has got 3 units, B has got 2 units and C has got 2 units. So, is a total of 4, 5, 6, 7, and since the banker only keeps 10 units, so the remaining 3 units are free and not allocated to any of the clients. On the other hand, the maximum credits for each client is 9, 4 and 7 respectively. So, you note that 9 plus 4 plus 7 is the maximum credit limits, which totals to 20 units, and this maximum credit limits is declared by the client in advance. Now, given this particular table, the banker should be able to allocate the maximum credits to users in such a way that no unsafe state is reached. So, let us see this with examples. So, the problem we are trying to solve here is whether these allocations maximum of 9, 4 and 7 can be made to A, B and C in such a way that the state is safe, or rather such an allocation can be made. So, let us say we start with 2 units being allocated to B. So, we have 3 units in the free store. Out of these 3 units, 2 are allocated to B, therefore, B has now 2 plus 2, that is 4 units, and the free store now has 3 minus 2, that is 1 unit free. Now, after B completes, all the 4 units are returned to the free store. So, 4 plus 1 will be 5 units present in the free store, and these 5 units can then be allocated to C. So, C will get its maximum credit limit of 5 plus 2, that is 7 units as seen over here. So, the amount present in the free store is 0 units. Now, after C completes, all the 7 units of C get returned back to the free store. Now, the banker could allocate the resources required by A, that is the maximum resources required by A, that is of 7 more units, to get its maximum credit limit of 9 units. So, we have 9 credit units allocated to A and 1 unit which is free. Thus, we see with this particular start point or this particular state of the system, where there are 3 units free and there is maximum of 9, 4 and 7 units as the credit limit of each client can have. We see that with this particular state, there is a schedule which is possible, so that all requests and all maximum requests by the clients can be fulfilled. So, we call such a state as a safe state, and the banker could go ahead and make such allocations. Now, let us look at another example where the state we start with is that A has 4 units with it, B has 2 and C has 2. So, a total of 8 units are present with A, B and C respectively, and the number of free units is 2, and the maximum credit limits of each client is as before 9, 4 and 7 respectively. Now, we see that irrespective of how the banker tries to allocate these remaining units to each of its clients, there is no schedule which is feasible that could fulfill these requirements. For example, suppose B were allocated 2 more units, and you see that given that there are only 2 units free. So, B is the only client which can be serviced. Therefore, B gets 4 units while there are 0 free units present. Now, after B completes, we have 4 units free, but you see that neither A, which requires 5 more units, nor C, which requires 5 more units as well, can be serviced with 4 units, which is present in the free store. Therefore, we see that this state is an unsafe state, because there is no scheduling order which can cater to these requirements. So, this is an unsafe state, and the banker should ensure that such a state is not reached at any point. So, a similar mechanism can be also implemented in the operating system, where corresponding to each request, the operating system will determine if the system is in a safe state, and if indeed the system is in a safe state, indicating that there is a schedule of the resources, so that all requests can be granted, then the requests are allocated. Otherwise, the request is postponed until later.